Hi girls. Today we're going to be talking about Unit 3, Lesson 3.1.4, Solving Exponential Equations. To begin with, let's do a little review of the laws of exponents. Now your textbook calls it the laws of exponents, but other textbooks call it the properties of exponents. And we've already discussed these, but let's do a quick review. Remember that when we have a power, we have a base and we have an exponent. B is our base, and in this case, x is our exponent. So we have a rule. If we have two powers that are being multiplied and they have the same base, so b to the m times b to the n, two powers, both with the same base, they're being multiplied, we add their exponents, b to the m plus n. In a real case, 2 to the fifth times 2 to the second, two powers being multiplied, they have the same base, so we add their exponents. 2 to the fifth, 5 plus 2, gives us 2 to the seventh. So when we have powers, when we're multiplying powers with the same base, so if you multiply powers with the same base, then you add the exponents. Next, we have the situation where we have a power, and now it's being raised to another exponent. So it's a power to a power. In this case, we multiply the exponents, b to the m times n. So in our example from before, we would take 2 to the fifth, and we're raising that power to another exponent, and that becomes 2 to the 5 times 2, 2 to the 10th. So if we're taking a power and we're raising it to another exponent, then we multiply the exponents. And then one of our last examples is when we talk about the property of zero. And as we know, any power with an exponent of 0 gives us 1. So b to the 0 is 1, 2 to the 0 is 1, 8 to the 0 is 1, everything to the 0 is 1. Now the last thing we need to remember, and that's really important to what we're going to be doing today, is what we do when we have negative exponents. So let me change colors for that. So negative exponents. So if I have b to the negative n, I can rewrite that, and I need to rewrite that so that it has a positive exponent. In order to get it to have a positive exponent, I have to move it down to the denominator. So I place 1 over same base, but now I make the exponent positive. 1 over b to the n. So an example would be 2 to the negative third. I want to make that exponent positive. So I'll put 1 in my numerator, take my base down to my denominator, and make my exponent positive. 1 over 2 to the third. Same situation, but this time I'm starting with 1 over b to the n. So I need to figure out what my base is if I don't have it in a fraction. So if it's already in the denominator and I want to take it out of the denominator, then I know that means it's a negative exponent. So 1 over b to the n becomes b raised to the negative n. So in our instance before, if we have 1 over 2 to the third, I want to figure out what that is with a base of 2. That becomes 2 to the negative third. So we'll do this a few times in our examples and it'll start to feel easier. Next step in the process, we're going to start solving exponential equations. So here are the steps we're going to take in each of these problems. We're going to rewrite the bases as a power of a common base. Step 2, we're going to substitute the rewritten bases into the original equation. Step 3, we'll simplify the exponents. And step 4, we'll solve for the variable. So let's just work a few of these. So now I need you to get your workbook, and I want you to go to page 39. So let's look at our first guided example. It says to solve 4 to the x equals 1024. Now, this is an exponential equation because our exponent is where our x is located. But we need to figure out what that x equals. So the first thing we need to do is get these so that they both have a common base. This side has a base of 4, so I need to be able to write 1024 so that it has a base of 4. So let's get out our calculator. And we know we can take 4 to the first power is 4. 4 squared is 16. So let's figure out what we have to raise 4 to. Let me get my calculator here, see if we can see that. There we go. What do we have to raise 4 to get up to 1024? So let's take 4 to the third power. 4 to the third power is 64. 4 raised to the fourth power is 256. 4 raised to the fifth power. There we go. 4 raised to the fifth power gives us 1024. So we're going to rewrite the base as powers with a common base. So that means 4 to the x, and 1024, I can write that as 4 to the fifth. Four to the x equals 4 to the fifth. Now, 4 to the x equals 4 to the fifth. The bases are the same, so obviously that means that the exponents have to be the same. Over here I'm raising 4 to the fifth. Here I'm raising 4 to the x. They have to be equal, so that means x equals 5. If we check our answer, we know that. 4 to the fifth equals 1024. All right, let's go to example 2. It's on the back of this page. It says solve the equation. So we've got 1/2 raised to the x is equal to 16. So here I want to find a way to get both sides so that they have a base of 2. So let's just leave this side alone for a minute and figure out how to turn 16 so that it has a base of 2. We know 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16. So I can make this 2 to the fourth. Now I need to figure out what to do with my 1/2. Well, I have 1 over 2 to the first. Since it's in my denominator, I know that if I wanted to make this so that it had a base of 2, it would have to be a negative. It has a positive exponent of 1 now, so now it has a negative exponent of -1. And all of that is being raised to the x. Well, I have a power being raised to another exponent, which means I have to multiply my exponents. So this becomes 2 to the -1x is equal to 2 to the fourth. So I have the same base on both sides of my equation, so I can equate my exponents. So -x equals 4. I need to find what positive x is, divide both sides by -1, x equals 4. Example 3. I have a base of 7 here. I need to turn 49 into a number that has a base of 7. Well, I know that 7 squared equals 49, 7 to the x. And again, I have my power in my denominator. It has a positive exponent. If I want to write this so that I have 7 as my base, my computer just stopped. I want to make sure it's still recording. There we go. All right, still recording. So it's in my denominator. Bring it out of my denominator. That's going to be 7 to the negative 2 is equal to 7 to the x. Bases are the same. Set the exponents equal to each other. So x is equal to negative 2. And remember, in one of our lessons earlier, I wanted to make sure that you started writing these so that the exponent was on the left-hand side. All right, and our last example. So solve the equation 117 equals 5 to the x minus 8. Now, I need to get x by itself, so the first thing I need to do is get rid of that negative 8 here. So I'm going to add 8 to both sides, which is going to give me 125 is equal to 5 to the x. Well, I know 5 squared is 25. Multiply that by another 5, that would give me 5 to the third is equal to 5 to the x. Same bases. Set the exponents equal to each other. So x equals 3. All right, so let's do some more practice. This is basically your homework. So I need you to get your textbook out. Go to page U334, and we're going to do these 10 problems together. And do this on a separate sheet of paper so that when you come in tomorrow, you can hand this in. This is essentially your homework. So go ahead and pause the video, get some paper, and get your textbook out. All right, so let's get started here. I've got 2 as my base here, so I need to write 16 so that it has a base of 2. And of course, you hear my dog barking in the background. All right, 2 squared is 4, 2 to the third is 8, 2 to the fourth equals 16. So 2 to the fourth equals 2 to the x. They have the same base. All I need to do is set the exponents equal to each other, so x equals 4. Let's look at number 2. Wow, that's a really big number. But I know I have 5 to the x here, so I know I need to find a power with a base of 5. Well, we know 5 to the third is 125, so let's do a few more of these. So let's take 5 to the fourth, 625. 5 to the fifth, not yet. 5 to the sixth, there we go. So 5 to the sixth equals 15,625. So I've got 5 to the x is equal to 5 to the sixth. My powers have the same base, so I set the exponents equal to each other. X equals 6. Number 3. I have a base of 4 here. I need to write 16, so it has a base of 4. So that's 1 over 4 squared is equal to 4 to the x. My power's in my denominator, so I know that means to get it out of the denominator and write it so that it just has a base of 4, I have to make that negative. So 4 to the negative 2 is equal to 4 to the x. Set my exponents equal to each other. X equals negative 2. All right, 4. So I know this large number can be written as 6 to a power. 6 squared is 36. Let's try 6 to the third. 6 to the third gives me 216. Let's try 6 to the fourth. And there it is, 1296. So 6 to the x is equal to 1 over 6 to the 4th. Again, it's in my denominator. So I bring it out, and I have to give it a negative exponent now. So x equals negative 4. All right, number 5. 27 equals 1/3 to the x. So I want to write both of these so that they have an exponent, or they have a base of 3. 27, 3 squared is 9, times 3 again. 27 is going to be 3 to the 3rd. And in this case, I need to write it so that it has 3 as its base. So if it's 1/3, then I know if I want to find the reciprocal, I could make that a negative exponent. So 1/3 is 3 to the negative 1. And that's being raised to the x. So 3 to the 3rd, now I have power to a power, so negative 1 times x will give me 3 to the negative x. I can equate my exponents. 3 equals negative x. I have to divide both sides by negative 1. So I've got negative 3 is equal to x, so x is equal to negative 3. There's another situation that looks like this. I know I need to have both of these sides so that they have a base of 7. So 1 over 7 would give me 7 to the negative 1 raised to the x. 49 is 7 squared. Power to a power again. So 7 to the negative x is equal to 7 squared. Negative x equals 2. Divide both sides by negative 1. X equals negative 2. Number 7. My base is 3. I need to write 81 so that it has a base of 3. So in our last example, we saw that 3 to the 3rd is 27. Let's try 3 to the 4th. There we go. That's going to give us 81. So 3 to the 4th is equal to 3 to the x. 4 equals x. X equals 4. Now this one looks scary, but it's really not. I need both of these numbers to have a base of 0.2. Well, we know 0.2 to the 1st is equal to 0.2. 0.2 squared, if we do that in our calculator, gives us 0.04. 0.2 to the 3rd power gives us 0.008. That's what we need. So this becomes 0.2 to the 3rd power is equal to 0.2 to the x. Bases are the same, even though they're a decimal. Set our exponents equal to each other. So x equals 3. All right, and here's one that looks like one of the examples that we did. We do not have our power by itself, so we can't start solving for x until we get this all by itself. So we're going to subtract 6 from both sides. That's going to give us 125 is equal to 5 to the x. 5 squared is 25. 5 to the 3rd gives me 125. Equate my exponents, so x equals 3. All right, here's our last one. Again, my power is not by itself, so I need to get rid of anything around it. I'm going to subtract 4 from both sides. This gives me 8 is 512 to the x. So I want both of these to have a power of, or a power with a base of 8. So we know that 8 squared is 64, so let's take 8 to the 3rd power. Oh, there it is, 512. So 8 equals 8 to the 3rd, and that's being raised to the x. So I have a power to a power again. 8 equals 8 to the 3x. So I don't have an exponent over here, but we know there's a 1 there even though we don't write it. So in this case, my bases are the same. I can set my exponents equal to each other and solve for x. So 1/3 equals x, and when we rewrite it, we get x equals 1/3. All right, let me show you this. Nice job. Make sure you have these 10 problems done and ready to turn in tomorrow when we get to class, and we'll practice a few more problems when we get to class. See you tomorrow.